have you ever imagined a planet with two faces? Mars, the red planet, a symbol of cosmic mystery, holds a secret that has puzzled scientists for decades. When you look at Mars from above, it becomes clear. This is a world split in two. One hemisphere appears battered and ancient, covered in scars left by eons of impacts. The other is oddly smooth, youthful and enigmatic, as if it has been reborn. What force split Mars in half? And how has this cosmic rift shaped the evolution of the red planet? Join us on a journey into the heart of the great Martian asymmetry. Begin by picturing the Martian surface as a planet divided. Nearly 2/3 of Mars's surface, the southern hemisphere, forms a high, rugged plateau, pockmarked by countless craters. This is Mars's ancient memory, an untouched record stretching back nearly 4 billion years. The land here rises and falls in jagged relief, every crater a silent witness to the violence of the early solar system. By contrast, the northern hemisphere is almost eerily flat, covering just 1/3 of the planet's surface, with far fewer craters. This northern plain looks as though it has been smoothed and rejuvenated by some enormous event, its geological history rewritten. The mystery deepens just below the surface. Studies reveal that the crust in the north is remarkably thin, only about 32 kilometers deep, while in the south it thickens to a massive 58 kilometers. Even the Martian magnetic field tells a split story. The southern highlands preserve strong remnants of an ancient magnetic field, hinting that Mars once had a dynamic, molten core. Yet in the north, that memory has been erased. No magnetic vestiges remain. What force wiped away the magnetic history of the north? Why did the southern crust keep its ancient secrets while the north was stripped bare? Mars's asymmetry doesn't stop at the land and rocks. It extends to the very air. Towering dust storms, some of the largest in the solar system, often ignite in the southern hemisphere. This is no coincidence. Mars follows an elliptical orbit around the Sun, and with its axis tilted at 25 degrees, the southern hemisphere endures summers when Mars swings closest to the Sun and winters when it drifts furthest away. The result? Southern summers are blistering, driving massive storms and extreme weather, while the winters are bitterly cold. The climate in the south is far harsher than in the north, amplifying the divide between these two worlds. Perhaps the most tantalizing clue lies in the lost water of Mars. Geological evidence suggests that the northern hemisphere was once home to a vast ocean, Oceanus Borealis. Ancient shorelines, river channels, and even the scars of two immense tsunamis, likely triggered by asteroid impacts, mark the edges of this vanished sea. For millions of years, water may have flowed and pooled in the north, possibly nurturing primitive life in a distant Martian past. But what caused this profound split? Scientists have proposed three main theories. The first and most widely supported is the giant impact hypothesis. Around 4.5 billion years ago, in the chaos of the early solar system, a massive celestial body, perhaps 1 to 600 to 2 to 700 kilometers wide, smashed into Mars at a glancing angle. The result was the Borealis Basin, the largest impact scar in our solar system. This cataclysm would have vaporized the crust in the north, erasing the magnetic field and sculpting the flat plane we see today. Some scientists believe this same impact may have even created Mars's two small moons, Phobos and Deimos. From the debris, hurled into orbit. The second theory points inward to the planet's own restless heart. According to this idea, a giant plume of hot material, an upwelling from deep within Mars's mantle, rose up beneath the southern hemisphere, thickening the crust and preserving its magnetic memory. This churning mantle may also have fueled the formation of the Tharsis volcanic plateau, home to Olympus Mons, the largest volcano in the solar system. In this scenario, Mars's asymmetry is the legacy of powerful forces welling up from its own interior. A third, less favored hypothesis imagines not one, but many impacts in the planet's northern regions. Over millions of years, a barrage of smaller asteroids could have battered the northern hemisphere, gradually erasing its craters and smoothing its surface. However, this theory struggles to explain the sheer scale and uniformity of the northern lowlands, and so most scientists view it as unlikely. Modern science continues to probe the Martian divide. Data from NASA's InSight lander has revealed stark differences in the density of the crust between the hemispheres. Some researchers have even suggested that the real culprit may be a giant impact in the south, not the north, flipping the traditional narrative on its head. Meanwhile, evidence from Valles Marineris, the Grand Canyon of Mars, suggests that this region was once a vast hydrothermal province, a potential cradle for ancient Martian life. The debate is far from settled, and each new discovery adds another layer to the puzzle. This great asymmetry has shaped every chapter of Mars's story. It influenced how the planet cooled and why its global magnetic field faded away. It paved the way for the rise of the Tharsis volcanic province and the towering Olympus Mons, 3 times the height of Mount Everest. Most importantly, it created the northern lowlands, the basin that once held an ocean and may have cradled life itself. The Martian divide is not just a geological phenomenon. It is a key to understanding Mars's mysterious history, its present state, and the tantalizing possibility of its future. Is the split the scar of a primordial collision, or is it the signature of forces stirring from within? Only future missions, robotic explorers, and perhaps even human footsteps will help us unravel this cosmic riddle. And perhaps, in the ancient seabeds of the North, we will find the ultimate discovery, proof that life once existed beyond Earth.